Hi girls, so look, I'm just sharing this video here with you for anyone who needs a little bit more assistance with the homework, okay? We obviously went through this question here today. Remember, it's always to do with these two things here. Auxiliary plan, projected from the elevation, depths taken from the plan. Auxiliary elevation, projected from the plan, heights taken from the elevation, which were the examples we did here today, where we projected from the plan view, looking at it, and we took our heights from the XY line up. Likewise with this one, we projected from the plan, looking at the object. Imagine we were standing here looking at it in this direction, where we took our heights from the object up. Okay, so same principle here today, all right, or on this video. So what we're going to do, guys, is it says here, shown is a pictorial view of a solid. Pictorial meaning 3D. Okay, so I'm just going to write that bit of information there. Sorry guys, left my nice pen. There we go. Shown is pictorial view of a solid. So pictorial view means 3D. Just so we're aware, there's the 3D view of the solid. The front elevation of and plan are also given. So they've given us the elevation. Now look at the object here. They've given us. They told us surface A is there. There's surface A. So it's like we're looking at the object in this direction. So there's a little stick figure here, looking in that direction at it. Okay, and obviously the bird's eye view is when you're a bird looking down on top of it. Okay, so when you're a bird looking down on top of it, we see all this surface. When we're a person looking in this direction, directly in front of it, we can see this face here, this rectangle, and we see surface A. And it's like we're seeing them here, and they look the same size here, but in reality we know, okay, they look the exact same here, but in reality we know that surface A is much longer than this surface here. But this surface right now, when we're standing in this direction, the elevation looking directly at the object, as we're positioned, okay, as they've given the view here, that's how I know I'm positioned roughly there. That shape there, this one on the right hand side, is a true shape. However, surface A is not a true shape because I'm not looking directly at it when I'm standing here. Okay, so it says here, project an auxiliary elevation in the direction shown in order to show the true shape of surface A. So they've asked us to get the true shape of surface A, but we're going to get the whole object as well. Okay, so this is how we're going to do it. First of all, I'm going to use my highlighter. I'm going to highlight this surface. I'm just going to use green this time. So this is the surface we want to get the true shape of. There's a very inky highlighter. So there's the surface I want to get the true shape of. So if I was to colour that up here, well, that's this surface. Okay. And what's helpful about that then is, in the plan view, I see that surface as a line. And we've discussed this a couple of times in class. That's my surface there in the plan. After bleeding a little bit. But more importantly, I see it as a line. And then when we see a surface as a line, that is called our edge view. Okay? When we see an edge view of a surface. Now, very important here. We can only ever see the true shape of a surface or project the true shape of a surface when we see a surface as an edge view in either plan or elevation. In this case, I'm seeing my edge view in the plan. Therefore, I'm going to be projecting from the plan and taking my heights, project from the plan, heights taken from elevation. That's the concept, okay, that we have to kind of drill into our heads. So how do we do that? And we practice it today in class, okay? It's like I'm a little, where am I after leaving it? Here. It's like I'm a little stick figure. There's my head, there's my shoulder, and I'm looking in this direction. So can I see surface A? Yes. And I'm looking perpendicular to it. Okay, a little right angle there, I'm looking perpendicular to it. So then when I look at it, I will see its true shape. Can I see a bit of this face here? Yes, I can. Now I understand I'm here. It's not like I'm off looking like this. Remember, I'm just looking here. So it's like, imagine I was standing over here and I was still looking in this direction. So yes, I can see a bit of this face here. Look, if you look at the arrow, can we see a bit of this face here? Yes, we can. The faces we can't see are this one and this one. Okay? So that's what we have to look at. Now I'm just going to label some points here. On surface A, I'm going to label this one 1, 2, 3, and 4. And let's say we also had this point out here. I'm going to go with 5, 6, and I'd labeled this terribly. I'm going to say this point here is 7 and this point here is 8. So if I was to label them over here in my views, how do I go about that? Well, this point out here, if you look at my object over here, is obviously number 6. Then the one underneath it is 5. Okay, this point here is 4. And I've got 3 there. Okay, and then I've got 2 on top. And I've got 1 underneath. But what other points are directly measured? Remember now we're looking at the elevation here. What other points are behind 1? Well, behind 1 is number 7. So I'm going to put 1, 7 there. And 2, 8. Let's label them in our plan. So 6 and 5 have to be down here in the plan. So it's 6, 5. Then I'm going to say 3, 4. This point here is 2, 1. And then 8, 2. The reason I'm just saying a certain number first, 6 before 5, is because 6 is on top. So I technically see that first. See 3 first, I see 2 first, and I see 8 first as I look down. Okay? So, look guys, some of us probably understand that already and have cracked on. You didn't need to understand, maybe have me explain that, but it's important for our own understanding. So now what we're going to do is, we're looking in this direction. So I'm setting up, remember now here, we're setting up an auxiliary plane that's going to be parallel to the edge view. And then what happens really in reality is that flips down flat. So how do I do that? Using sliding set squares. So I'm going to zoom out for this first part. So parallel to the edge view, I usually set up the long side of my 45-degree set square. You can see how I'm doing that there. Get the set squares kind of like this. I put the long side onto it. I'm just moving it down so I have room to slide up. I'll visualize it in the way here, guys. So there's my long side sitting on it. Slide it up, and always just have it out. There's no need to kind of just outside. See there, XY line, and that's going to project up. I'm going to go a little bit higher actually. Sorry, I will actually go up to about here. Okay. No, I'm going to keep it down though. I'm just thinking how that's going to project. Yeah, I'm going to go about here. I think it's fine. So that there is now going to be, I'll go here. I'm going to go here. And I'm going to label it like this. Look, X1, Y1. You don't have to put them on both sides all the time. So there's my X1, Y1. And now if I rotate my set square, still using the same side to draw it, I'm now going to project up every point. I'll project up 6 and 5, 3 and 4, okay, and now I have to rotate my set squares, guys, because my visualizer is in the way. I can just use the lines now that I projected to go parallel to. You can see how I'm doing it here. Extend them a bit further if you need to. Project them just a little bit further. And now 2 and 1. And 8 and 2. Okay, it's kind of gone into my text there, but that's okay. And now what we're going to do is we've projected up, and look, X1, Y1, and our lines have gone perpendicular to it. Okay, so all we do here now, rule of thumb, I'm going to zoom in. We've projected from the plan, we take our heights from the elevation. That means take your heights from the XY line up. If we project from the elevation where it would be going down this way, if we had the edge view up here, then we'd take our distances from the XY line down. So now I want to find, look, from the XY line up to 1. Now technically, you'll get onto this later in the topic in the next week or so. If an object is kind of floating in midair, you can see this object is above the ground, it's floating. We could technically eliminate that space. I won't get into that yet, because all I want you to understand is measure from the XY line up. So take your distance from the XY line up to 1, which is the same as the distance up to 7, 4 and 5. So for 1, I'm going to follow 1 out onto the X1, Y1, mark it. Okay, now you could also do this for 7. Where the hell is 7? How did I get that wrong when I labeled it? Oh my god, that should have been 7 there. So yeah, I absolutely made an absolute hames of that. Oh my god. So that would have been 1 and 2, which was correct, and this should have been 8 and 7 here. Made an absolute hames of that as I labelled it. Apologies. So you'll see that they're at the exact same height. A little thing, when points are at the same height, you could just do this as well. You could do sliding set squares, and it saves me using my compass 4 times. and points are at the same height, I could just do that. Okay, because you'll see here when I come down to find, say, point number 4, which is on there, matches up the same height, see? And when I go to find point number 5, same height. So now I'll do the same thing. Look, if I want to find number 6, 6 is the same height as 3, same height as 2 and 8. So for 6, mark it up from the x1, y1. So I took the height from the xy line, found 6 down here, followed it out to the x1, y1, mark it up. Okay, same thing again. I'm just going to do a bit of sliding set squares here, parallel to the x1, y1. It's like we're just drawing another elevation, but it's at this lopsided angle. Now mine has slightly gone into the into my kind of text there, girls. So apologies. Just have to move here. Right. So let's heavy all that in now. So heavy all this in. So that's heavy. That is heavy. There we go. Okay, now that is, and in there is my surface A. So just to highlight this, if I was to get another colour, just for our own understanding. So imagine there's a red face there, and a red face there. Okay, so obviously up here would be red in the elevation. Okay, down here, if I was just to put that in red there, that in red there. Okay, we can kind of get the idea. So remember, we're looking in this direction. So this face here is the red face. This face here is the other red face. And more importantly, the surface A, which is my green face, but more importantly is my true shape. So have I drawn the object? Yes, I have. And does it include the true shape of surface A in this view? Yes, it is. It is an elevation, but it is what's called an auxiliary elevation. Okay, where I've kind of looked at it in such a way that I will see surface A as a true shape. Okay, now when we're doing orthographics, always remember at the end of every question, what do we have to check for? Hidden detail. So how do I check for hidden detail? Now, if you're looking at the object, I can see the red face here. If I was to do my labels here, sorry, I should have labels. There's 1, up here is 2. I had, is it 4 here? I had 3 up here. I think I had 6 out here, and there's 5. And then over here I have 7, and then 8 was up here. Hard to see in the text there, but you get the idea. Now, is there another edge at the back? Yes, there is. There's an edge in there. That will go down there at the back, over here like this, and across, okay, if we were to make a 3D object. So where is that edge? Well, that's coming from there. When I'm standing here looking at it in this direction, as I said, we can see the red face, and we see the green face as a true shape. I'm going to write in that. Sorry. Phone just going there, guys. Apologies. True shape. But more importantly, the edge here at the back, so parallel sliding set squares to the projection lines, which were perpendicular to the x1, y1, the auxiliary plane. I'm going to project up this one. And technically, right in here at the back, I would have an edge in there. That edge in there is my hidden detail. Okay, so this face here, look from 8 to 70 here, is like this rectangle. There's the 8, 7 edge. So that's like that back face there. Okay, this face is the 6 to 5 one going to the back one, so 6 to 5 going to here. Then I've obviously got the red face as we work around it. So that's the idea. It's like we took ourselves standing here, looking in this direction, straight at it. Okay, so there you have it, girls. That there is a long way of explaining that question. So hope you found that video helpful. That's the question done there. Alright.